Criterion, reference, reliability, and validity. Objectives. Define a criterion reference test. Explain the development, advantages, and limitations of criterion reference measurement. Select appropriate statistical tests and interpret the results for a criterion reference measurement. Discuss and interpret epidemiological statistics. Criterion reference test. A criterion reference test, a CRT, is constructed to yield measurements that are directly interpretable in terms of special or specific performance standards. Performance standards are generally specified by defining a class or domain of tests that should be performed by the participant. Used to make categorical decisions, example, pass, fail, or meeting a standard, not meeting a standard, is typically involve nominal data, or the nominals numbers, remember, although may include continuous data as well, and CRTs involving continuous data use cutoff scores to separate participants into categories. Developing criterion reference standards, the judgmental approach, based on the beliefs of experience of experts, or the normative approach, use norm reference data to set standards with a theoretically accepted criterion. The empirical approach uses an external criterion measure, and the combination approach involves use of multiple available scores, experts, prior experience, empirical data, and norms. The advantages of a CRT, or criterion reference standards, represent specific desired performance levels that are explicitly linked to a criterion. They are independent of the proportion of the population that meets the standard, and their specific diagnostic evaluations can be made to improve performance to the criterion level. Their achievement is based on reaching the standard, not on bettering someone else's performance level. And performance is linked to specific outcomes. Participants know exactly what is expected of them. Cutoff scores always involve some subjective judgments. Misclassifications can be severe, and participants who attain the cutoff level may not be motivated to continue to improve. Statistical analysis of CRTs. With CRTs, data needs to be categorized into nominal variables, and they're categorical in nature. For CRTs, the primary tool for analysis is a statistical technique using a contingency table, or a chi-square. Here's a 2x2 contingency table for criterion reference tests taken over 2 days. You see you have day 1, day 2. Statistical techniques to use with CRTs: a chi-square, a phi coefficient, proportion of agreement, or a kappa. The chi-square test is a test of associations between nominally scaled variables. Logically, we want there to be an association between trials. This can be computed in SPSS using crosstabs. And SPSS is just a statistical software program. Your phi coefficient, a special case of the ppm correlation coefficient between dichotomously scored variables, ranges from -1 to +1, with 1 indicating perfect association with 0 indicating no association. It can be computed in SPSS using crosstabs or correlation. Proportion of agreement, established by adding the proportions themselves, are consistently classified. Ranges from 0 to 1. The higher the value, the more consistent. Correct the classifications. It does not account for chance. Kappa, widely used technique that allows for correction for chance agreements. Most appropriately used to assess inter-observer agreement or to examine the agreement between a predictor and a criterion that is nominally scaled. Theoretically ranges from a -1 to a +1. Its higher value indicates more consistency, and sensitive to low values in the marginals and small sample contingency tables. Here's interpretation of kappa. If it's less than 0.2, you're in poor agreement, and then you can see slight agreement, moderate agreement, and then 0.6 to 0.8 is a substantial agreement. Here is a test reliability example. Norm reference and criterion reference reliability both share similar types of reliability and validity: equivalence reliability and stability reliability. And here's criterion reference equivalence reliability between the 1 mile run or walk and pacer. It's between boys and girls, 2 trials. Criterion related validity, concurrent validity, comparison of a test to the gold standard, or construct validity, overlap of 2 divergent groups measured on a continuum. And here's comparison of the 2 CRT validities. You got a fitness program and physical best. You got chi-square, your phi coefficient, your percent of agreement, and your kappa. Construct-related validity. Setting cutoff scores can be accomplished using the divergent group method with two groups that are clearly different. The distribution for each group is plotted. The point in the curves where the scores overlap is used as criterion cutoff scores. A theoretical example of the divergent group method. The receiver operating curve analysis, ROC, is an example of construct-related CRT approach. The ROC technique maximizes the number of discriminations between those who achieved the criterion and those who did not. Applying criterion reference standards to epidemiology. Descriptive epidemiology seeks to describe the frequency and distribution of mortality and morbidity according to the time, place, and person. Epidemiology may help identify risk factors of mortality and morbidity. And analytical epidemiology pursues the causes and prevention of mortality and morbidity. Here is a research design in that. You see, you got your experimental and your observational. And this is random community trial. And then here's what you've observed.